Well, hey guys, you can see here we've got a graph. I've got a Cartesian plane and I've got a straight line drawn onto it. Imagine if this straight line was a ramp and you're walking up it. If I move my line now to look more like this, you would say it's gotten steeper. And if I keep going up, it gets steeper and steeper and steeper. So let's pull that line back down and let's put the equations on them. And as we get steeper, let's have a look at what happens to the number here. My equation for this line is y equals 1/3 x. As it gets steeper, it's now 1/2 x. 1x, because there's an invisible 1 here. 2x. 3x. You'll see as my line gets steeper, this number in front of the x gets larger. And this number is it's a measure of how steep the line gets. It got larger as we got steeper, and we call it the gradient. So the word gradient basically just means that it's a measure of how steep a line actually is. So let's look at this line here, y equals 2x. Now this number here in front of the x actually is our gradient. But let's look at some other ways that we can calculate it. So if I've written it in this form, y equals something x, the number in front of the x is our gradient. It's the measure of how steep our line is. But there are a couple of other ways we can work this number out. Let's say, for example, I started right here at 0 and I came across 1. To get back up onto the line, I'd have to go up 2. What about if I did it again? Come across 1, up 2. And you start to see this number 2 here is also representing our gradient. So the gradient of this line is 2. In other words, every time I go across 1, I have to go up 2. So that's one other way that we could calculate the gradient. We could take the number in front of the x, or we could say, well, one step across gives me how many up. That is also my gradient. But there's another way as well. Now, before we get on to that, we use the letter m traditionally to represent gradient. So when we're talking about gradient, we use the letter m. We'd say that the gradient for this line, or m, equals 2. Now there is another way. If I took 2 points, any 2 points on my line, I could make a right angle triangle out of them with a horizontal and a vertical. The vertical distance we call the rise. The horizontal distance we call the run. So I've got my right angle triangle here. It's got a run and a rise. Now where does that matter? Where do we use the rise and the run? Well, first of all, let's measure them out. My rise here goes up 2 boxes. My run comes across 1 box. Now this is important because we have a little formula that you should remember and know how to use. We can also calculate the gradient by creating a fraction with the rise on top and the run on the bottom. Now in this case, I've got a rise of 2 and a run of 1. 2 over 1 also equals 2. And there it is again. It was the number we had up here. It was our number of how many we had to go up whenever I came across 1. And I can also calculate it by rise over run. Now what if I took 2 different points? Does it matter? Do I have to take these 2, or could I take any 2 points on the line? Let's have a look and see if it still works. In this case, I've taken these 2 points. I've got a run of 2. It comes across 2 boxes. And I've got a rise of 4. 1, 2, 3, 4 boxes to get back up. So let's put those numbers now into my fraction. Rise of 4 over a run of 2 gives me 2. So no, it doesn't matter which 2 points. I'm always going to end up with the same gradient when I do rise over run, so long as the points are on the line. Let's have a look at another example, not so steep this time. Here's the equation y equals 1/3 x, and you can see I've got a run of 3, 1, 2, 3 boxes, and a rise of 1. So if I put them into my rise over run formula, I get 1/3. In other words, the gradient, or the steepness of the line, is 1/3. What about lines, though, that go the opposite direction? Everything we've done so far has gone up to the right. But what about lines that go up to the left? Do the same rules apply? Here's the equation of this line. It's y equals negative a half x. We've still got a rise and we've still got a run. In this case, I've got a rise of 2. My run is 4, but it's in the negative direction. 1, 2, 3, 4, heading down towards the negative numbers. So I'd say it's got a run of negative 4. Let's put them into our rise over run formula. And I get 2 over negative 4, which of course simplifies to negative 1/2, which was the number in front here. So I'd say the gradient for this line is negative 1/2. So that sort of wraps it up, but a couple of little important things here. Lines that slope up to the right have a positive gradient. We've seen that in the first two examples. Lines that slope up to the left always have a negative gradient. So going back to our original example, this line slopes up to the right. It's got a positive value for its gradient. Hey, great job. If you're doing this in a classroom context, I'm going to pause now and let you copy down the example, the diagram, and the notes. Well done, everybody.